Sir. We would like to ask a couple of questions.
Please do.
I have a question actually regarding the math modules. If it is possible, I would like to ask you about that.
Please do.
Okay. Yeah, it's been now more than 1 year now since math modules has reached to many specialists and children in Turkey. Again, in the light of past theory, we know that in order to be successful in maths or to do maths, there is no need for, like, for example, solving lots of problems or doing a certain arithmetic operation over and over again in order to learn a mathematical concept, as you said before. Yeah, can you share your opinions and insights about how can we make children to love to do maths? Yeah, we know actually, yeah, we are teaching to do specialists about this program, but I think they would like to hear from you as well.
How to make them interested in math, right?
Yes.
Okay.
Especially why we should focus on more cognitive processes rather than doing operations, doing again and again.
Yes, yes. Well, I think you know the answer. By grade 3, and this is written by one of my British friends, Peter Brand, by grade 3, and his wife Nunes, by grade 3, most children lose interest in math because of the way we teach them. They have lost interest. Now, why we should do the concept work first, I think I have done it in a little picture that comes with the introduction to math. And here is the picture in my board, an overview. It says that math can be divided into 2 parts. As you know, computing and word problems. Simple.
Yes.
Now, computing depends on learning the operations. And word problem depend on understanding the question. Now, we think that computing is computing. Just learning how to add, subtract, divide, multiply. What goes before we learn these skills, or what goes along with learning these skills? In the diagram, first it needs planning and executive functions. Cognitive flexibility, changing your set, shifting gears, inhibiting impulsive responses. Some of them may be superstitious responses that you have already learned, how to inhibit those, and depend a lot on working memory. We always use working memory in math operations. All of these really boil down to attentional control. How do we control our attention? How do we allocate attentional resources? So, as I told you, through inhibition or impulses, in fact, many people believe that ability to inhibit is the essence of intelligence. No.
Yes.
There's a fellow called Dempster who said this maybe 10 years ago. And shifting. That when a strategy doesn't work, let's shift. So don't you think these are essential strategies?
Definitely.
As we illustrate it through mathematical operations.
Yes, definitely. You need them.
By the way, you might have seen that our math module has a whole 100 pages of supplementary tasks.
Yes.
Have you seen that?
Yes.
Of course.
Yes.
We are using it.
Yes. A couple of my special education graduate students made up all those instructional tasks. They are synchronous with the Alberta curriculum. So they're not something very esoteric. But they took the task themselves and then each of the math module tasks and made them like a game.
Mm-hmm.
Yes, children are really having fun.
Pardon?
Children are really having fun when they are doing.
Yes, having fun. And the other is word problem. If 10 apples I buy 10 apples with 20 cents, how many apples can I buy with 10 cents? Now, my first visit to Moscow, when I went to see Luria, I was introduced to a special education class. So it's very funny to see that class. The kids are all straightened up and sitting on desks. And so the teacher said, ask this question: how many apples such and such? So it's a special education class. So the teacher then says, let's break it down. We're talking about apples, she says. Apples. So the kid, we're talking about apples. And Luria says this in his little vignettes about teaching. He says, when you are teaching mathematics, kids get tired. So give them 2 minutes to do this, to this, to this, and then calm down. They're very practical there. Okay. Now, so you break down the problem, and we find that word problems can have mostly a simultaneous processing, because we have to study the grammatical nature of the sentences and the logical nature of the sentence. So Luria called simultaneous processing logical grammatical analysis.
Mm-hmm.
And it could be a verbal simultaneous processing. It could be a non-verbal simultaneous processing. You know what's a non-verbal simultaneous processing? Is like progressive matrices figures.
Yes.
It's a non-verbal simultaneous processing. And many people in the West think that that is essential intelligence, culture-free. I think they're completely wrong. If you take language completely away from intelligence, we are left with silent people.
Yes.
We are mute.
Yes.
So language cannot be taken out of intelligence. So those of us who believe that there is non-verbal intelligence, they're deluding themselves. All non-verbal intelligence is translated into speech. Some kind of speech. Internal speech, yes. Images, yes. Ideas, yes. So that's why we need to learn these basic skills before we prepare them for doing, say, mental arithmetic or high-speed additions. When my daughter was in the classroom in grade 1, she was given 20 questions. 2 plus 1, 3 plus 2, 5 plus 2, 1 plus 3. And she has to write it down. And the teacher said, my daughter's name is Sheila. Sheila is slow. So we said, Sheila, what's the problem? He said, the teacher wants me to make mistakes. I can't do that.
She's right.
So, I still remember it. Or you are teaching a little kid subtraction. You say, suppose you have 10 candies. You give away 3 to your friend. What remains? We call that subtraction.
Mm-hmm.
The kid says, no, mom, that's called sharing. So these are the fun part, as you said,
Yes.
of learning math.
Okay.
Thank you very much, sir. It was a really detailed explanation.